Okay. Now for this equation, 2x plus 1 equals 2. Okay. 2x plus 1 equals 2. Right. Now, for looking at this equation, first notice the domain of the variable here is all real numbers. Just like before, the right-hand side, there's no restriction there. The left-hand side, that's where x is, the variable, but you could put any number in for x. There's no restriction there. You could put any number in for x there. You could take any number, you could multiply it by 2 and add 1, and you'll get something that makes sense. So the domain here is all real numbers. All right, good. Well, let's try plugging in some numbers and see what happens. There's no restriction, so we can plug in anything we want. So when x is 1, we could plug that in. We get 2 times 1 plus 1 on the left, which is 3. But then the equation is saying 3 equals 2. Well, that's false. So when x is 1, the equation is false. When x is 0, you can see the equation is also false. Right? On the left side here, we have 2 times 0 plus 1. That's just 1. On the right side here, we still have 2. So we get 1 equals 2. False. What about when x is a half, though? Well, in that case, we get 2 times a half plus 1. That's equal to 1 plus 1, which is 2. So we get 2 times a half plus 1. That's equal to 1 plus 1, which is 2. That's on the left side. So we get 2 equals 2 for the whole equation. Well, that's true. That's a true statement. So we found a value of x where if we replace x by that number, a half, the equation becomes a true statement. This is what we call a solution to this equation. So of any value of the variable, okay, any value of the variable that makes the equation true, when you plug it into the variable, so let me say it again, any value of the variable that makes the equation true, we call that a solution. Some people call it a root of the equation. It's called the solution of the equation. And the process of finding those solutions, we call that solving the equation. The process of finding all solutions, that's called solving the equation. Okay, that's good. Okay, that's good. So, when you're solving an equation, you're looking for all solutions. And in fact, the collection of all solutions of an equation, that's called the solution set of the equation. Again, this is more terminology. This is the solution set of the equation. And building on that, 2 equations that have the same solution set, we call them equivalent equations. We call them equivalent equations if they have the same solution set. Now, just to let you know, a set could be empty. It could have nothing in it. So an equation that has no solutions, that solution set is empty. Okay, good. All right. Okay, so we know what it means to solve equations. We know what a solution is. Well, how do we actually solve equations? I mean, here we just basically guessed. Guessing's really not the way you want to approach this. It's not that effective. And it's boring. What you can do, however, is you can manipulate or algebraically manipulate an equation into something that's easier to deal with. You can algebraically manipulate an equation to get another equation that's easier to deal with. Deal with meaning find its solutions. But you can't do anything you want. There's a restriction. In other words, you can only use these manipulations. You can simplify either side of the equation. You can add or subtract the same expression to both sides. When I say with the same domain, they mean the same domain of the variable as the original equation, the one you're working on. It's not really going to be an issue for us, though. So you can add or subtract the same thing to both sides. You can multiply or divide both sides by the same non-zero number. So you could do that. And you could also interchange both sides of the equation. That is something else you can do. You can interchange both sides of the equation. All right, good. So again, those are the manipulations you're allowed to use when solving an equation. All right, that's good. Now, the kind of equation, I mean, really, let me just say this. This really applies to any kind of equation. These are the things you can do to solve it. For now, though, we're going to look at what are called linear equations. And that's an equation that can be written this way. In other words, it's equivalent to this. Another way of saying that is if you can manipulate the equation and rewrite it in this form. So you can obtain this equation using the manipulations here. Why do we only use these manipulations? Because the solution set doesn't change. I forgot to say that, but I guess I'm saying it now. You can only use these manipulations, though, because the solution set is not changed by these. In other words, the equations you get, they're equivalent to what you started with. So with that in mind, a linear equation in one variable, that's an equation that's you can manipulate, you can write it in this form. It's equivalent to this. A, B, and C are numbers, A is not 0. And one example of that is this equation, x equals d, for any number d. And generally, the way we solve linear equations, okay, we're going to manipulate them to get x equals something, because this equation is easy to solve. The only solution is d, whatever that d is. I mean, here it's not terrible, but here it's a lot easier. Okay. Are there any questions so far? We're going to do some examples now. So I know it was a lot of stuff I just said. I understand that. I hope it made sense on some level. Okay. So let's actually solve this equation. And generally what you want to do is you want to get x all alone. You want to get x equals something, right? That's what we said before. You want to get x all alone on one side and everything else on the other side. So we have 2x plus 1 equals 2, right? We're going to subtract 1 from each side first. We want x to be all alone. So we get 2 times x equals 1. We get that first. okay? So 2x equals 1. We don't want 2x, we want x though. So let's divide both sides by 2, right? We're manipulating the original equation. We're getting a new equation. X equals a half. Well, excuse me, 2x over 2 equals a half. But this is the same thing as x. So we get x equals a half. So the first equation is equivalent to this equation here. It's equivalent to this, as you can see. So these two have the same solution sets. And this, this is easy to solve. The only solution there is x equals a half. So the solution set for the original equation is a half. People use these curly braces to actually denote a set. I mean, you're not going to have to write a solution set on my exams, but I still wanted you to see what a solution set is. Okay. So that's our first example. Let's do some more.